What if I told you there's a single, simple piece of code that kind of runs everything? From your drive to work to a planet orbiting the sun? Well, today, we're going to unlock one of the most fundamental formulas out there. Let's get right into it. Think about it. Every single day, whether you realize it or not, you're asking these questions. How fast do I need to go? How much farther is it? How long is this going to take? These are the basic questions of motion, and it turns out they all share one single, powerful answer. And that answer is a formula. But don't let that word scare you. It's surprisingly simple. Just think of it like a universal code that connects speed, distance, and time. And once you learn this code, you really start to see the world a little differently. So here it is. This is the whole shebang. D equals RT. Yep, just 3 little letters, but they've got the power to map out pretty much any journey you can think of. This simple equation, it's the key to everything we're talking about today. Okay, so what do those letters actually stand for? Well, D is pretty easy. That's distance, how far you go. R is for rate, which is just a slightly more formal way of saying your speed. And T, well, T is for time, how long it takes. So distance equals your rate multiplied by your time. That's really the core of it. But here's where this formula gets really, really useful. It's flexible. And to unlock that flexibility, we use this little guy, the triangle. Now, it's not just some silly memory trick. It's like a master key. It lets us instantly rearrange the formula to find whatever piece of the puzzle we're missing. Check out how easy this is. Let's say you want to find the distance. You just cover up the D with your finger. What's left? R next to T, so it's R times T. Need to find the rate, your speed? Cover the R. Now you've got D over T, so that's distance divided by time. And for time, you guessed it. Cover T and you're left with distance divided by rate. It's a genius little system that makes sure you get it right every single time. Okay, now, there is one really, really important rule for any of this to work. It's the golden rule, you might say. And it's this. Your rate, your speed, has to be constant. It absolutely cannot change. No speeding up, no hitting the brakes. We're talking one single, steady speed the whole way. In the math world, when a rate is perfectly steady like this, they have a special name for it, the constant of proportionality. They usually call it K. But look, for our purposes today, just think of K and R as basically the same thing. It's that one unchanging speed that makes this whole thing tick. So, that brings up a really good question, right? It's one thing if someone just tells you the constant speed, but what if you're just looking at some data, like how far something went and how long it took? How do you figure out the constant rate for yourself? Let's use a super simple example. Imagine a car drove 120 miles and it took exactly 2 hours to do it. Okay, so we've got our distance and we've got our time. Now we just need to find that constant rate. Finding that constant, RK, is actually really straightforward. All you have to do is take the total distance, which is our y value here, and divide it by the total time, our x value. That's it, just distance divided by time. And when we do that math, 120 miles divided by 2 hours, we get 60 miles per hour. And there it is. That's our constant rate, our K. It means that for every single hour that went by, that car traveled exactly 60 miles, perfectly consistent. And here's something cool. If you were to draw this on a graph, with time on the bottom and distance going up the side, a constant rate will always make a perfectly straight line that starts right at 0. That straight line is like a visual fingerprint for constant, steady motion. All right, we have the formula. We've got our master key triangle, and we understand the golden rule about the constant rate. So now it's time to put it all together and tackle a real-world problem. Here's our challenge. There's a train, and it's moving along at a nice, steady, constant speed of 50 miles per hour. The big question is, how long is it going to take for that train to travel 200 miles? So let's break it down. First step, let's just list out what we know. We know the distance, D, is 200 miles. We know the rate, R, is 50 miles per hour. So the thing we don't know, our question mark, is the time, T. Okay, step 2, let's go to our triangle. We need to find time, so we cover up the T. And what's left? Distance over rate, D divided by R. So our equation is T equals 200 divided by 50. And 200 divided by 50 is 4. 4 hours. That's our answer. It's going to take that train exactly 4 hours to travel 200 miles. See how clean that is? Once you know the steps, the formula just gives you the right answer. No guesswork. And there you have it.
the D equals RT formula, that handy triangle, and the all-important rule of constant rate. This is your new toolkit. You can use this to figure out any situation that involves steady, constant motion. It's a seriously powerful bit of knowledge to have. But that leaves us with one last really interesting question, doesn't it? I mean, we live in the real world with traffic lights and stop signs. We're always speeding up and slowing down. So what happens to the math when the rate isn't constant? What happens when things accelerate? Well, that's a story for another time.